Britain's digital railway.
Since the earliest days of rail, trains have been controlled by their very own highway code to keep them a safe distance apart. Every railway line is divided up into sections called blocks, where only one train at a time is allowed to be. Signalling has kit attached to tracks to determine whether or not a train is in a section. This kit includes track circuits, which send a small electrical current between the tracks and the trains, and axle counters, which count the wheels going in and out of a section. If the numbers match, the section is clear for the next train. Trackside signals control entry into and out of each block, and also warn trains when the line ahead might be occupied and if they must reduce speed. And just like on a road, there are also speed limit signs, reducing speeds in built-up areas and where there are hazards. There's lots of ways to make sure everyone stays safe, as Bex and Dan find out.
Come on! What are we waiting for?
Oh, we stopped at a signal. You know, one of those traffic lights by the side of the line.
Can you see it?
Let me look. Yeah, it's red. That means stop. Did you know that the latest signals are controlled by computers that know exactly where all the trains are and what speed they're going?
That's pretty cool. But how do they make sure trains followed the rules before electric lights and computers?
I think they used flags to make the signals.
Bex is right. In the earliest days of rail travel, policemen would stand along the track and use flags to tell train drivers if the track ahead was clear. But as they couldn't communicate with neighbouring policemen, the only way to do this was to time each train as it came past and leave a set amount of time before letting the next one past.
But what if the previous train had stopped unexpectedly? There might be a crash.
As trains started to get faster and more frequent, things had to change. Mechanical semaphore signals controlled by signalmen were introduced. The signalmen could now also communicate with each other using bells and lamps. There were two main types of semaphore signals. A stop signal consists of a red, square-ended arm with a vertical white stripe. When in the horizontal position, a stop signal must never be passed, as the line immediately ahead may not be clear. At night, a red light would show when set at danger and a green light when clear. The second type was called the distant signal. It has a yellow arm with a black chevron and a V notch cut out at the end. It tells drivers to be careful as they approach the next stop signal. Whilst it may be passed, a driver must slow his train to be ready to stop at the signal. From the 1960s, traffic light signals began to be used to control trains, with signals able to show cautionary yellow as well as stop and go, red and green, as well as being easier to see, as they were controlled by relays and computers rather than mechanical metal rods. They are more reliable. With modern technology advancing all the time, signalling has definitely come into the 21st century. The railways use a train detection system, which can tell signallers exactly where every train is and how fast they're going. There are also systems that can automatically stop trains if the driver doesn't take the correct course of action or passes through a red signal, all helping the railways to run smoothly and safely.
And we're off! Green for go!
Britain's digital railway, with support from the Royal Academy of Engineering. Find out more at bunkidslive.com/railway.